Welcome to 10th class maths class. Let's start the coordinate geometry class now. Okay, we'll follow as usual. We'll follow the Telangana class 10th book for this one. Okay, these are the topics we are going to learn: introduction, similarity of triangles, basic proportionality theorem, then criteria for similarity of triangles, areas of similar triangles, Pythagoras theorem, Baudhayana theorem, and then different forms of theoretical statement. And all the exercises we'll cover in this. Okay. So let's see the introduction now first. Okay. This is chapter 8 of Telangana syllabus. Okay. So let's start. Let's say you saw it a tall tree, okay, or a mountain or a big building structure, and you want to measure the height of this tall structure. Okay, it can be a tree, mountain, building, or anything else, a pole, street, electricity pole, anything you want to measure the height of it. What are the ways you can measure? Okay, so since you cannot reach to the top of the structure, okay, there is a another way we can try. Okay, so the one explained here is you get a mirror, okay, and keep it at some distance and try to adjust your position in such a way that you are seeing the top of the structure. Okay, in this case there is a tree here, okay, there is a mirror at C, okay, and she is trying to look at the mirror, okay, and she's trying to find the top of the tree. Okay, once you hit the top of the tree you stop there basically. Okay, now this forms two triangles, okay, that is ABC and DEC, right? Okay, there are two triangles formed. Now you have information, these two triangles, are they the same? Definitely not, because the tall structure is very tall and the line CD also will be very long, CE also will be long, correct? So it is not possible to tell that, I mean, it is possible that, it is very much possible to tell that these two triangles are not same. But what are they? And how do you find the height of a given tall structure from this experiment? Is it possible? Okay. So these two triangles, we cannot call them congruent or same, okay, but they are similar figures. They are similar figures, and let's learn what are the similarity rules which are required to tell that two figures are similar. Okay, and this is the method which our ancestors used to measure the distance between distance between, I mean, sun and earth, moon and earth, and all these things. Okay, so let's learn the concept. If you look at these pictures given here, okay, you have a car here, and I try to just increase the width of the car. Okay, then this is what it becomes. Are they same? Are they similar? Okay, or I take the first car and then just increase the height of it. Okay, so now out of these three cars, are they same or are they similar? Are they what kind of cars these are basically? Okay, what you call? Okay, they're exactly not same cars, definitely, because each one has a different dimensions and the dimensions don't have a correct ratio, right? Not same ratio. So they resemble each other as a car because they functional as car, but they are not same. They are basically, we can call them they are distorted figures basically, correct? But if you take another example where you have a photograph with you and you print it in different sizes, okay? You print it in three different sizes. Now, can you tell me that these three figures are exactly same or similar? Okay, so these three photos are not same because their size is different. But we can definitely tell they are similar because they have exactly same picture in a enlarged version, right? So second one is bigger than first one, and third one is bigger than second one, and first one already. So we can call these as the similar figures, correct? Now let's take an example of a polygon, which, okay, if you have a regular polygon in which all sides and angles are equal is called a regular polygon. So if you take a regular polygon, all uh, different sizes of regular polygon are of basically of the same number of sides. Okay. If you take a pentagon of different sizes, regular pentagon of a different sizes, they are all similar. Correct? They all look same because their ratios of sides and all the angles are same. Correct? Okay. What are the other examples which you can think of regular, I mean, figures which are similar? And what is the fact? What is the rule required for this similar figures? Okay. The ratio of corresponding sides referred to as scale factor. Okay. So this is most important thing. The scale factor of a two images should be same in all the aspects to tell they are similar. Okay. If you take a polygon, all the sides should have similar ratio. Okay. That is what scale factor is. Correct. Okay. So scale factor we use many places. The best example is if you see any old map actually, Indian map or state road map, railway network map, bottom on the right bottom they write uh, the scale factor. Okay, they will write 1 centimeter equal to 1 kilometer or centimeter equal to 10 kilometers. They will write like that. Okay, with that we can measure two stations, basically two stations railway network, measure the distance there and just multiply with scale factor. Okay, if it is let's say 5 centimeter, then if the scale factor is 10 times, then we will say that the distance between the two stations is 50 centimeters. So this is one of the best example of using a scale factor. Okay. Of course, if you see any real map today, whether it is a printed map or the Google Maps or any mobile phone maps, they are basically similar. They are just diminished version of the actual map, actual city. Correct? So that is one example. And if you see all the regular polygons, okay, if you take one square, all the squares are basically similar. Okay, they are all similar because they have their sides are in the equal ratio. If you compare the innermost square with the second innermost, okay, their sides are always in the same ratio. They have same angles. Okay, if you take equilateral triangles, okay, all equilateral triangles are similar. All circles are similar. Correct. So these are the condition for similarity of shapes. Okay. Now let's do some activity to understand it more. Okay, you at your home or at school, basically what you do is you have a light on the top of the table. Okay, keep a light on the top of the table. Take a rectangular version of a cardboard. Okay, rectangular version of a cardboard and put it uh, in between light and the table. Okay, now you see the shade formed on the table. Now you mark the corners of the rectangular shade, okay, and you call them a dash, b dash, c dash, d dash. Okay, the actual cardboard is a b c d. Okay, so corresponding points you mark them as a dash, b dash, c dash, d dash. Now if you measure, okay, the shade is bigger than the rectangle, but all the sides, corresponding sides will have exactly same ratios. Okay, and all the angles are 190 degrees because it's a rectangle. You will find the four angles as 90 degrees, which is same as the original cardboard. Correct. So this is the rule for the similarity. Okay, so this is what we are trying to tell. All the angles are same and the ratios of sides are in the same ratio. Okay, so this emphasizes that two polygons with the same number of sides are similar if, okay, these are the two conditions. All corresponding angles are equal and all lengths of the corresponding sides are in the same ratio or in the same proportion, we call it, right? So this is the minimum condition which has to met to call two figures are similar. Okay. Is a square similar to a rectangle? Definitely not, because in a square all four sides are same. So if you want to have another similar figure, that figure also should have all four sides same. Rectangle don't have all four sides same. So they are not similar. Okay. Just if you see the angles, square has all the angles as 90 degrees, rectangle also has all the angles 90 degrees, but they are not similar because sides are not in the same ratio. Okay. Now, can you say that square and rhombus are similar? Square and rhombus have equal sides. Okay. In a square, all four sides are equal. In a rhombus, all four sides are equal. Okay. So the ratios of all corresponding sides will be same. But in a square, all the angles are 90 degrees. Okay. Each angle is 90 degrees. Whereas in a rhombus, only opposite angles are same. Not all four are not 90 degrees. So they are not similar. Okay. Are any two rectangles similar? Yes, rectangles can be similar provided you have a rule, right? You have to meet the condition. That is, corresponding sides should have same ratio. Okay, and of course, because both are rectangles, the angle criteria is met. So second criteria is corresponding sides should have same ratio. Okay, or same proportion. Okay. Now let's see this section. Fill in the blanks with similar or not similar. All squares are similar because it meets the criteria of same angles as well as same ratio of corresponding sides. All equilateral triangles similar, same reason. All isosceles triangles not similar because angles can change. Okay. Two polygons with same number of sides are dash if their corresponding angles are equal and corresponding sides are equal, then they are similar. Correct? They are actually not only similar, they are actually congruent or same because corresponding sides also equal the set. So it's exactly same polygon, right? So they are, you can call them similar, but they are much more than similar. They are actually same. Okay. Reduced and enlarged photographs of an object definitely similar there because there all the ratios will match. Rhombus and squares are not similar to each other. Okay. Any two similar figures are congruent. No, this is false. Okay. Unless until the ratio of corresponding sides is 1, they are not congruent. Okay. Any two congruent figures are similar? Yes, this is true. Their ratios of sides are in the 1. So you can still call them similar. Okay. Two polygons are similar if their corresponding angles are equal. Is this true? This is false. This is only one condition. You are not meeting the second condition, which is ratio of corresponding sides should be same. Okay. Third, give two different examples of pair of similar figures. Uh, you can have lots of things we have seen just now. Squares, all equilateral triangles. Okay. So yeah, you can have so many other examples. All the right angle triangles with side, let's say 3, 4, 5 as the right angle sides, and then other one is in the proportion of let's say 6, 8, and 10, right? Then they will be similar. Okay. Non-similar, so many things you can say rectangle and a square, pentagon and a rectangle. So I mean, you have thousands of non-similar figures example. Okay. Now let's learn the similarity of the triangles. Okay. When we say two triangles are similar, okay, we will first check the same rules. Corresponding angles should be equal and the lengths of corresponding sides are in the same ratio. This is the minimum condition we should meet to call any polygon as similar, right? So this is same applicable for triangle also. Okay. In ABC and DEC, from the initial question of looking the top of the pole or a tree in the mirror reflection. Okay, that example. Okay, angle A and angle D are equal. Okay, okay, angle B and angle E are equal. This is 90 degrees. We know these two are equal. Okay, angle ACB and angle DCE are equal. Okay, because light is light will incident ray and the return angle will be incident angle and the reflection angle will be same, right? So with that property, we can clearly tell these two angles are same. Okay. So these three angles are same. Now what about sides? Okay. DE by AE, DE by, sorry, AB equal to EC by BC, EC by BC and DC by AC. Okay, which are all same constant, that is K. Okay, this is nothing but scaling factor, right? Scale factor or scaling factor. Okay. Now, if this is the rule which is satisfied, then if this is the sides of the triangle and angles are same, okay, then we can call ABC similar to DEC. Okay, symbolically we'll write this way: ABC similar. Similar is like this. Okay, is similar to this one. Okay, the scaling factor, what it will tell, if k is greater than 1, then it's enlarged figure. K is equal to 1, they are congruent. Basically, k is less than 1, they are reduced or diminished figures. Okay, and you should write the order of the alphabets here: triangle ABC and DEC in the same way as equal angles. Okay, angle A and angle D are same, so A is first, D is first. Angle B and angle E are same, so B is here, E is here. Angle C, both have same term, so C and C. Okay, so this is how we write actually. This is the way of writing. Once you know this, you know the corresponding sides. AB is the corresponding side of AB is DE. BC corresponding side is EC. AC corresponding side is DC. Okay, this is you will know very easily. So this is how we should write it. Okay, now in triangles ABC and DEC, corresponding angles are equal. So they are called equiangular triangles. Okay. The ratio of any two corresponding sides in the two equiangular triangles is always the same. Okay. Once the angles of a triangles are met the are equal, basically met the first condition. Okay. Then triangle, for a triangle, basically you cannot draw another triangle where the corresponding sides are not in the same ratio. Okay, this is an exception for triangle. For a triangle, if three angles are same, okay, three corresponding angles are same, then we can say they are uh, similar. Okay, so this is how we can prove this. This is basic proportionality theorem we can use and prove it. This is also called Thales theorem. Okay, with this we can prove that angle, if angles are same of two triangles, okay, two triangles corresponding angles are same, then we can call them similar triangles. Okay, to understand this basic proportionality theorem, okay, let's do the activity given here. Okay, okay, take a any ruled paper, draw a triangle ABC, okay, and then you join other parallel line to BC. Okay, PQ and BC are parallel. Okay, now what do you observe? Okay, PQ is parallel to BC. There are two triangles. One is APQ and ABC. Correct? AP by PB. What happens? AP by PB and AQ by QC. What do you observe? Okay. So if you measure them, actually they will be same. The ratio will be same. AP by PB equal to AQ by QC. Okay. Because PQ is parallel to BC, all the ratios will be same. Okay. You can draw another parallel line on the top, right? So distance, I mean, any line passing through this set of these three parallel lines will have the same ratio. Okay. So now this is the basic proportionality theorem. Okay. Now based on this, we can derive the similarity of triangles. Okay. Okay. Thales theorem. Okay. If a line is drawn parallel to one side of a triangle, okay, that is DE is parallel to BC. Line is drawn, okay, and intersect other two sides of distinct points, that is D and E here, then other two sides are divided in the same ratio. Other two sides are divided in the same ratio. These two sides will be divided into same ratio. That's what it's telling. So let's see. In ABC, DE is parallel to BC. DE intersects sides AB and AC at D and E points. Okay, that's what then required to prove is AD by DB equal to AD by DB equal to AE by EC. This is the basic proportionality theorem, right? Okay. Now let's construct a perpendicular line DM. Okay, onto AC. DM is a perpendicular line. Similarly, EN is a perpendicular line. Okay. Now triangle area of triangle ADE. Okay, ADE. Okay, is equal to half into base, that is AD I am taking as base, so EN is the height. Okay? Half into AD into EN. Similarly, triangle BDE, if I take BDE, sorry, BDE, if I take this one, okay, this is also base is BD and height is EN, right? Height is EN only, correct? So area of triangle BDE is half into BD into EN. Okay. Now area of ADE by area of BDE equal to, okay, ADE by, if I take ratio of this one, what I will get is AD by BD. AD by BD. Correct? Now this is equation 1. Similarly, I take area of ADE as AE into DM. Now this time I am taking AE, this side AE into DM. Okay, DM is the height, AE is the base. Okay, and I take other one in triangle CDE, okay, CDE, base is CE, height is DM, okay, CE and DM. Now, if I take this ratio, this is AE by EC, AE by EC, okay. Now, observe that BDE and CDE are on the same base, DE, and between same parallels BC and DE, correct? BDE, BDE and CDE, BDE and CDE, okay, are between the same parallel line, okay, and their base is same, BC, correct? So obviously these two are equal triangles. Areas of these two triangles is equal, correct? If I draw a perpendicular line here, basically the area is perpendicular line, height into base, correct? Which is same. Okay, so from that I can, from 1 and 2 I can say that AD by DB equal to AD by DB, because these two are equal, right? So AD by DB equal to AE by EC. Okay? So that is AD by DB equal to AE by EC. Correct? So this is how we can easily prove the basic proportionality theorem. Okay. This is the very basic concept which we should understand to make sure that we apply it in several places in the similar triangles. Okay, we use extensively the similar triangle concept in mathematics and as well as in physics. Okay, so this is the very basic, you understand, uh, and go through this once again. This is the most basic concept to prove two triangles are similar. Okay, we will go to that part. Okay, as of now we proved that the ratios of sides are in the same ratio. Basically, it cuts the side into equal ratios. Okay, that is AD by DB equal to AE by EC. A parallel line cuts into equal, right? So this is the basic proportionality or Thames theorem. Okay, now you can try this activity. This is very easy to understand. You can try it. Theorem 8.2. If a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. Okay, this is the reverse of the previous theorem. We are trying to prove the reverse of it, basically. So what is given is there is a line cutting the triangle ABC at D and E points, okay, on AB and AC respectively. Now it is given that AD by BD or DB equal to AE by EC. It is given. Okay. Now we need to prove if this is the ratios which the line is cutting the triangle, then DE is parallel to BC. That is what we should prove. This is the required to prove. Okay. Now let's assume that DE is not parallel to BC. Okay, we are trying to prove by negation technique. Okay, this is called negation. So first we'll think the negation is correct. Okay, so we assume that DE is not parallel to BC. Okay, so we draw another line which is parallel to BC. We assume that this is parallel to BC. Okay, so DE dash is parallel to BC. Okay, now according to the previous theorem, if you draw a parallel line to the one side of the triangle, then it cuts the other two sides in same proportion. Correct? That means AD by DB equal to AE dash by E dash C. Correct? As per the previous theorem, this is what is correct. Now, AE by EC equal to AE by EC is equal to AE dash by EE dash. Why this is? Because it is given. AE by EC is nothing but AD by DB. So AD by DB is AE dash by E dash C. So these two will be equal. Both the RHS side will be equal. So AE dash by EC equal to AE by EC. Correct? That means E and E dash are same. They are the coincident. They are coincide. Right? This should be same point. Okay, so this is the proof of the reverse of same thing what we learned just now, proportionality theorem. Okay, let's do this. Try this section in a PQR triangle. E and F are the points on uh, sides PQ and PR. Okay, for similarity sake, this is PQR. Then uh, Q and R are here. PQR. Then E and F are here basically. Okay, E and F are here. Okay. So as per this one, PE by EQ should be equal to PF by FR. That's what we learned. So now they gave some numbers. With this, we should check if EF is parallel to QR or not. Okay. So PE by EQ is 3.9 by 3, which is 1.3, right? But PF by FR is 3.6 by 2.4, that is around 3 by 2, right? So they are not equal. So EF is not parallel to QR for the first case, not parallel. Okay. In second case, 4 by 4.5, okay, and 8 by 9. Okay, if I look at actually, if I double 4, I get 8. If I double 4.5, I get 9. So the ratios are same. 4 by 4.5 equal to 8 by 9. So this is EF is parallel to QR in this case. Second case. Okay. Third case, PQ by PR is 1 by 2. 1.28 by 2.56 is 1 by 2. And PE by PF is 1.8 by 3.6, which is also 1 by 2. So this is also EF is parallel to QR. Okay, so this is how we'll find out. Okay, now in the following figures, DE is parallel to BC. It is given DE is parallel to BC. Now we need to find EC. Okay, so if you say EC here, so 1.5 is 2 times is 3. So 1 centimeter, so 2 times, which is 2 centimeters. So EC is 2 centimeters here. Correct. Similarly here, 5.4 to 5.54 centimeters by 1.8. So that is one third basically, right? Or three times here. Uh, 1.8 by 5.4 is one third basically. So you need to get a one third of 7.2 is what you should get here. Okay. So 7.5, 7.2 by 3 is 2.4. So AD is 2.4. Okay. Now let's construct a division of a line segment. How to do this? There is a method given here. You can read it, but other method is more easy. So let's discuss about this. You take any angle, basically AB and X like this. Okay. Now you want to cut these two sides into proportion. Okay. How do you do? You draw a AX at an acute angle AB. Okay. And then okay, so this line, how much it is not exactly, you can divide into required number of uh, ratios. Okay, so you take another bigger line where you can easily uh, uh, easily point let's say 1 centimeter gap. So you construct another bigger line with an acute angle. Okay, now you cut the AX line with uh, 5, basically 5 points with the same gap. Okay, this is easy because this is a bigger line. Now With this, you draw a parallel. First, you join A5 and B. Okay, this is the triangle now. It has formed A5. This is the triangle formed. Now you try to draw a parallel line from A4, parallel line to A5B. Okay, then it will cut at a point where it is proportional now. Okay, similarly, A3 parallel line you draw, A2 a parallel line you can draw, A1 you can draw a parallel line, similar to this one. Okay, so this is the easy way to construct required ratios of lines. Okay, next, let's do this example problem. In a triangle ABC, DE is parallel to BC, which is given AD by DB equal to 3 by 5. Okay, this is AD by DB is equal to 3 by 5. AC equal to 5.6. AC, complete this one is 5.6. Find AE. That's the obstacle. Okay. So if AD by DB is equal to AE by EC, we know this. Okay. So how can we get AC now? AD by DB is given as 3 by 5. So AE by EC is also 3 by 5. So which means they are in the ratio of 3 is to 5. Correct? AC is in the ratio of 3 is to 5. Okay. So AE by AC minus AE, which is nothing but EC I am calling as AC minus AE, which is equal to 3 by 5, or AE by 5.6 minus AE equal to 3 by 5. So I just simplify it, I'll get AE value which is 2.1. Okay, or you can divide into ratios. Okay, eight parts is basically uh, this ratios, then you will get the individual values, then sum them up basically. Next, in the figure, LM is parallel to AB. LM is parallel to AB. AL is given. AL is given as x minus 3. AC is, that is big one, 2x. BM is given x minus 2. BC is given 2x plus 3. Find the value of x. Okay. So AL by LC equal to BM by MC. This is what we know. Proportionality theorem. Right? Basic proportionality theorem. Now x by 3 minus LC is nothing but AC minus AL, right? That is 2x minus x minus 3 equal to x minus 2 by 2x plus 3 minus x minus 2. Now you simplify it with cross multiplication or whatever. You get a quadratic equation x square plus x minus 6. Okay. So, sorry, this is the quadratic equation you will get. Okay. And if you simplify, what the value you will get is 2x minus 15 equal to x minus 6, or x is equal to 9. This is the value you will get. Okay. Now, let's do this section. In the given figure, what values of x will make D is parallel to AB? Okay, this is the triangle. Okay, AD equal to 8x plus 9, CD equal to x plus 3, BE equal to 3x plus 4, CE is x. So we know the ratio. If this DE cuts these lines into this ratio, only then the DE is parallel to AB. Correct? So substitute the values. Okay, x plus 3 by 8x plus 9 equal to x by 3x plus 4. Do the cross multiplication. This is what you will get. And then simplify, you will get a quadratic equation 5x square minus 4x minus 12 equal to 0. Okay, it will have two values, x equal to 2 or x equal to minus 6 by 5. Length cannot be negative, so ignore it. X is equal to 2. Okay, x is a factor, but if you substitute minus 6 by 5, CE will become negative, right? CE cannot be negative. C is equal to x. X cannot be negative. Okay, so x equal to 2. Next. Okay, again another triangle where DE is parallel to BC, which is given. So AD equal to x, DB equal to AD, DB, AE, and EC. All four are given. Just find x. So same thing we will apply. Template is same, so you can do exactly same. X equal to 4. Okay. Now let's go back to the lesson here. Some more examples are there to the exercise 8.1. Okay, the diagonals of quadrilateral are ABCD. Okay, this is the quadrilateral. They intersect each other at a point O. Diagonals are intersecting AC and DB at O, such that AO by BO equal to CO by DO. Prove that ABCD is a trapezium. Okay, that means DC is parallel to AB. That's what we have to prove. Okay. Okay. So let's draw a line through this O. Okay. Parallel to AB. Parallel to AB, which meets DA at X. Okay. This is where it meets. Now, in triangle DAB, okay, DAB, this XO is a parallel line to AB. It's parallel to AB, correct? So, which means dx by AX equal to DO by OB, correct? Dx by XA equal to DO by OB, right? Next, AX by XB equal to, okay, I'm just basically writing the reverse. AX by XD equal to BO by OD, okay? Now, AO by BO equal to CO by DO, which is given. This is given data. So, AO by CO, I am just moving CO to the denominator and BO to the numerator. So, AO by CO equal to BO by OD, which is same as this equation 1, right? So, AX by XD is equal to AO by CO. AX by XD equal to AO by CO. So let's look at AO by CO. What is AO by CO? AO by CO. Okay. Not only DO by OB, it is also equal to AO by CO. Correct? Which means, what is the meaning of it? That means that line basically XO is parallel to DC. This XO line is parallel to DC. That means, correct? OD by DB and OA by OC. Okay. And AB is also parallel to DC. Means, right? So this is how we can prove. If the ratios basically you have two parallel lines, okay, you draw another parallel line which will cut these diagonals into the equal ratios. So these ratios will be are same basically. That's what you are trying to prove using this. Another one. In a trapezium ABCD again, okay, AB is parallel to DC. EF are the points on non-parallel sides. Okay, AD and BC respectively, such that EF is parallel to AB. It is given that EF is parallel to AB. Show that AE by ED equal to PF by F3. Okay, so this is simple. You draw a diagonal AC. Okay, now it forms a triangle, right? ADC triangle where EG is parallel to DC. Correct? So AE by ED equal to AG by GC. Correct? By basic proportionality theorem. Now, you take another triangle, that is ABC triangle. Okay, ABC triangle. Here, GF is parallel to AB. GF is parallel to AB, okay, which means AG by GC equal to BF by FC. Correct? AG by GC equal to PF by FC, which means from these two equations you can derive AE by ED equal to PF by FC. Okay, let's get into the exercise. Let's do exercise 8.1. Okay. In triangle PQR, ST is a line such that PS by SQ equal to PT by TR. Okay. It is given that PS by SQ equal to PT by TR. And ST is a line. And also angle TSP, okay, this angle equal to angle PRQ. Okay. This angle is equal to this angle. Okay. Prove that PQR is an isosceles triangle. Okay, this is very simple. You can read the question there, but it's very easy to explain here. Okay, we know that if PS by SQ equal to PT by TR, ST is parallel to QR. Correct? ST is parallel to QR. Now, which means there are two similar triangles. Correct? And okay, you don't need to go to similar triangles. Okay, ST is just parallel to QR, right? Which means this angle is equal to Q. Angle S is equal to angle Q. Why? Because they are ST and QR are parallel lines and PQ is a transverse, right? So these two angles are equal. Similarly, P and R also equal. But it is also given that S and R also equal. Okay, S and R also equal, which means R and Q also will be same. Okay, because S is equal to Q, right? If these two angles Q and R are same, then triangle PQR is isosceles triangle, right? That is how we'll prove. Okay, next. In the given figure, okay, let's see the figure. LM is parallel to CB. LM is parallel to CB. Okay, and LN is parallel to CD. Okay, LN is parallel to CD. Prove that AM by MB equal to AN by ND. Okay, so if you take ABC as a triangle here, okay, ABC as a triangle, then LM is parallel to CD. Okay, LM will cut the sides AB and AC in the equal ratio. Correct? So AM by MB equal to AL by L. Right? And similarly, we have one more triangle ACD. Correct? In ACD also, line LN is parallel to CD. Okay? LN is parallel to CD, which means, okay, this LN line cuts the sides of triangle ACD in equal ratios. That is, AN by ND equal to AL by NC. Okay? So you have these two triangles are attached. One common side is there. So if the ratios are same, okay, and these two parallel lines are from the same point, correct? So if this ratio is same, that means uh, AM by MB equal to AN by ND, right? So from these two equations, we can say AM by MB equal to AN by ND, right? Next, okay. In the given figure, DE is parallel to AC. Okay, DE is parallel to AC and DF is parallel to AE. Okay, prove that BF by FE equal to BE by EC. Okay, yeah. So it is given that DE is parallel to AC. Correct. So which means BE by EC, right? BE by EC is equal to BD by DA or AD. Correct. Because DE is parallel to AC, it will cut into equal ratios, the side AB and BC, right? Now, in triangle, again, if you take this triangle ABE, okay, triangle ABE, DE is parallel to AE, which means BF by FE equal to BD by DA or AD, correct? So from these two things, we can equate the LHS side, which is BF by FE equal to BE by EC. Okay, next. So all these problems are introduction. Okay, these are not the uh, problems, real problems which you will get in exams and so. Okay, the real problems will be more complicated, but you will finally use same formulas, same theorems, same rules you will use. So to make you understand these theorems very well and it should get into your mind absolutely, these exercises are basically made. Okay, next. Prove that line drawn through a midpoint of one side of triangle parallel to other side, okay, and bisects the third side. Okay, this we have already proved, I think, before in the example. Basically, this is a reverse of this one, basic proportionality theorem. Okay. So what is given is PQR is a triangle. Okay, and ST is a line. Okay, it is given that PS equal to QS. PS equal to SQ. Sorry, PS equal to SQ. These two are same because S is the midpoint of PQ. Okay. Now this ST is parallel to QR. It is given that ST is parallel to QR. Okay. We have to prove that T is midpoint of PR. Okay. So this is easy because ST is parallel to QR. PS by QS equal to, correct? PS by SQ or QS equal to PT by TR, right? And PS by SQ is 1 because these two are equal. PS and SQ are equal, right? So PT by TR also will be equal to 1, which means PT equal to TR. So T is midpoint of uh, ST bisects the PR in equal parts. Or okay, T is midpoint of PR. Okay, next. Prove that a line segment joining midpoint of any two sides of a triangle is parallel to the third side, which is also again same reverse of basic proportionality theorem. It is given that PS equal to SQ and PT equal to TR. Okay, so we know the proportionality theorem. Uh, if PS by SQ equal to PT by TR, then ST is parallel to QR, right? Third side. And it is both PS by SQ equal to PT by TR, both are 1. So, which means ST is parallel to QR. Okay, next. In the given figure, DE is parallel to DE, okay, is parallel to OR. Sorry, DE is here. DE is parallel to OQ. DF is parallel to OR. Okay, EF, this is EF is parallel to QR. Okay, this is the triangular pyramid. So you have, if you remove the bottom, basically base, you will have three triangles on the slanting, right? Three slanting triangles you will have. On each triangle, you have a parallel line drawn, basically. And all the parallel lines are meeting at the same level. Okay. So this is given. Show that EF is parallel to QR. We have to prove that EF is parallel to QR. Okay. So we have one third common line for EF, right? So we have to take that one into consideration and then prove it. Okay. So DE is parallel to OQ, which means PD by DO equal to PE by EQ. Correct? PE by DO equal to PD by DO. Okay. Second, DF is parallel to OR. So in triangle POQ, okay. Similarly, PD by DO equal to PF by FR. Now from these two triangles, LHS side is same, so I will equate them. So PE by EQ equal to PF by FR, which is nothing but PE by EQ equal to PF by FR. So EF is parallel to QR. That means, right? Okay. Next. In the adjacent figure, ABC are points on OP, OQ, and OR. Okay. A, B, C are points on OP, OQ, and OR. Okay. Such that AB is parallel to PQ, AC is parallel to PR, BC is parallel to QR. Okay. Then, no, sorry. Only these two are parallel, which is given. We have to prove that third BC is also parallel to QR. This we have to prove. Okay. This is also same as the pyramid problem. If you are looking from top now. Okay. You are looking from top of the pyramid. Before you saw the pyramid from the side. That's the only difference. So it is exactly same. If you put the steps properly, the triangles which where the parallel lines are there, if you put them properly, you will get the answer. Okay. Exactly same problem. This is pyramid from the top. That is pyramid from the side. Okay. Imagine visually. Then you will understand easily. Next. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect at the point O. Show that OA by OB, OA by OB equal to OC by OD. Okay. So what we have to do is we have to draw a parallel line through O, cutting sides AD and BC at X and Y. Okay. Once you know that you have done this, you have two triangles here, right? Okay. The two triangles are in triangle ADC, ADC. Okay, this is one triangle you formed, right? In this triangle, XY is parallel to DC, which means OA by OC equal to AX by XD, correct? Right? And in ABD, okay, ABD in this triangle, again, okay, OB by OD equal to AX by XD. Okay. Why I choose which triangle you have to choose? Okay. Look at the question. Okay. We need OA by OB. We need OC by OD. Right. So this is what I'm trying to get into. Okay. Close value. Okay. So now I have OA by OC and I have OB by OD, which are equal. Okay. If these two are equal, I just readjust them. OC I will take it to the numerator. OB I will bring it to the denominator. Then OA by OB equal to OC by OD. Okay. Next. So just you have to visually uh, first interpret the diagram how it should look and then draw it properly and then you got the answer. Okay, these are very simple basic problem for you to understand the concept of similar triangles and parallel lines. Okay, now let's look at the criteria for similarity of triangles. Let us learn the criteria for similarity of the triangles. Okay, so what do you think when we call two triangles are similar? For a polygon, we learned we should have all the angles equal. Okay, corresponding angles should be equal, not within the polygon, but the corresponding angles. If it is ABCD and PQRS, then A and P angle should be same, and correspondingly each angle should be equal. Okay, and second condition is the sides should be in the same ratio. The corresponding side should be in the same ratio of the two polygons. What about triangle? Triangle also you require same rule that all angles should be corresponding angle should be same as well as corresponding sides should be same. Is it required or uh, only one of them is enough? Okay, let's see. Let's look at the activity first. You draw a triangle. Okay, draw a BC line, and at 40 degrees, one line you draw, 60 degrees, another line you draw. Okay, draw another line QR which is bigger than BC or smaller than BC, different from BC basically. And at Q again you draw a 40 degrees line, and at R you draw another 60 degrees line. Okay, now you know that 40 degrees angles are same. That is B and Q are same, and C and R are same. Now you measure what is the angle here. Okay, we know that angles in a triangle is 180 degrees, so obviously you will get 80 degrees here, right? Okay, and same thing here. Okay, so which means if two of the angles are same, third angle automatically will be same in a triangle. Okay, so do you need to now you need to check your criteria for similarity of triangles? Do we need all three corresponding angles should be same? Do you need to check all three angles? If you check only two corresponding angles, if they are equal, okay, first condition is already fulfilled, right? Correct? Okay, so that's what we are trying to do the activity here. Now next, okay. So AAA criteria for similarity of triangles. Okay. So in two triangles, if corresponding angles are equal, then corresponding sides are also in proportion. Okay. Hence, triangles are similar. Okay. This is the theorem which he is proposing. So let's prove this. Then that means we don't require to check proportionality of the sides if angles criteria is met. Okay. This is only for triangles. Okay. It is not for all polygons. Okay. Now there are two triangles ABC and DEF. Okay. ABC and DEF are there. Angle A equal to D. Okay. A is corresponding angle is D. B corresponding angle is E. C corresponding angle is F. Okay. That is how you write the order of the letter. Okay. Okay. Now AB by DE equal to BC by EF, AC by DF. This we need to prove, required to prove. Okay. Let's see. If AB is greater than ADE, suppose AB is less than DE. Okay, now you can take this triangle, put it on this one because angle A is same as angle D, so it will fit exactly overlaps on the bigger triangle, right? And you mark the length and draw a line PQ. Okay. Now DP is nothing but equal to AB. Okay. DQ is equal to AC. Okay. Correct. Now angle BPE, angle B is equal to angle P is equal to angle E. Why? I have put this triangle as is on top. Okay. Because these are congruent triangles now. Correct. DPQ is congruent to ABC. Correct. All the sides will be exactly same. All the angles will be same. Okay. So that means dP by PE equal to dQ by QF. Okay. Also, dP by PE is nothing but, okay, and also AB by DE. Okay. AB by DE equal to AC by DF. How this is possible? Because these two are similar triangles. Now these three angles are same. Okay. Angle D and angle A is same. Angle B and angle P is same. Angle C and angle Q is same. Correct. So we can say AB by DE equal to AC by DF. Okay. And from this, how do you prove this one from this one? DP by PE equal to DQ by QF. You just add plus 1 on both sides. Okay. If you add plus 1 on both sides, it will become DP plus PE by PE. Correct. DP plus PE is nothing but DE. DE by PE. Okay. Or you uh, reciprocal, you add 1, you will get basically uh, one side you will get AB, other side you will get DE. Okay. Okay, so AB by DE equal to AC by DF. This is what you will get. Very easy to prove this. You make PE by DP equal to QF by DQ and then add plus 1. So it will become PE plus DP. Okay, PE plus DP by DP equal to QF plus DQ by DQ. Okay, DQ is same as AC, DP is same as AB. Okay, and the bottom one you will get, numerator one you will get DE and DF. So reciprocal is this one. Okay. Now, similarly, we can prove the other two. Okay. So we can prove that if three angles are same, three angles of two triangles are same, then their corresponding sides are in the same ratio, which we can prove very easily. Okay. So remember this one. So with this one, we can say that we don't require to check angle criteria as well as side criteria for a triangle. Correct? If you check the angle criteria, two angles are same, then third angle is automatically same. So if you check two angles, then that is enough to prove that two triangles are similar because their corresponding sides will be automatically in the same ratio. Okay. So this is called AA rule of similarity of triangles. Okay. Now activity, let's see. Draw two triangles ABC and DF such that AB equal to 6, sorry, AB equal to 3, BC is 6 and AC is 8 and this. Okay. So if you see here, the corresponding ratios are 3 to 4.5 is 1.5 times, correct? And 6 to 9 is also 1.5 times, 8 to 12 also 1.5 times. Okay. Now, all the sides are in the same ratio, which is 2 by 3. Now you measure the angles of this one and cross check whether angles are uh, equal or not. This is the reverse of what we have proved above, right? Activity further. So to your surprise, you will get same angle. A and D will be same. B and E will be same. C and F will be same. Okay. So now let's prove the side criteria for similarity of triangles. Okay. Now there is a triangle where all three AB by DE is equal to AC by DF equal to BC by PQ. Okay, this is given. BC by, sorry, EF. BC by EF equal to AC by uh, FDF or FD. Okay, this is given. You have to prove all angles are same now. Reverse of what we proved before. Same way you take this triangle, put it on this. because two sides are same and third side also will be same, PQ, it will fit on this triangle exactly. Okay. Now you know that dP by PE equal to dQ by QF equal to, right? Because dP is nothing but AB, okay, and dQ is nothing but BC. So with this we can prove that PQ, this line is parallel to EF. Okay. Once these lines are parallel, we know that angle P is equal to angle E, angle Q equal to angle F. Okay. Angle P is nothing but angle B, angle Q is nothing but angle C. Correct. And similarly, other sides also we can prove same way. So you will get all the sides, all the angles are corresponding angles are same. Okay. So this is how we can prove. So the reverse was also correct. Where if all sides are in the same ratio, corresponding sides are in the same ratio for two triangles, then their angles are corresponding angles are same, and the two triangles we can call them similar. Okay, by criteria SSS. Okay. Now we have another criteria SAS, side angle side. We don't need all three sides to check or all three angles to check all the angles. If two sides and one angle, the angle between those two sides is same and two sides are in the same ratio, that is also enough to tell that two triangles are similar. Okay. You can check this activity. And this is to prove that SAS criteria. Okay. So AB by DE equal to AC by DF and angle is same. Okay, with this also, if you measure, you will get same angle, and if you measure the BC and EF, they will be in the same ratio. Okay. So this is the same theorem to prove that exactly same way we will follow. So you can have a look at yourself. So SKS is another criteria to prove similarity of triangles. Here, two sides should be in the two sides of a triangle and corresponding two sides of second triangle are in the same ratio. Okay. And the angle between the two sides is same. Okay. Only then we call these two triangles as similar triangles. Okay. Now let's try this. Name the criteria of similarity. Okay. So here we can easily measure these two lines are given as parallel. So this angle, angle H, both sides are same. And angle I will be equal to angle G because these two are parallel lines and GI is the transfer. So these two angles will be same. Third angle will be automatically same because we already proved two angles are same. Third will be same anyway. So this is AAA or AA criteria. These two triangles are similar. Which two triangles? HFG and HKI. Okay. You write in the proper order. Okay. Now these two. Okay. It is given that at M 90 degrees, it's a right angle triangle. At Q right angle triangle. And 3 by 6 is equal to 4 by 10. Right. 3 by 6 is equal to 1 by 2. 4 by 10 is 1 by 2? No. So this is not, uh, here we cannot say that these two triangles are similar. Okay, it is not. Here, 2 by 3 equal to 2 by 3, which means xy is parallel to BC. Okay, so you have two sides and angle A is common. Okay, in a triangle AXY and ABC, okay, angle A is common. So from side criteria, we can say that these two triangles are similar. Okay. Same thing here. 3 by 5 equal to 2 by 2 by 10 by 3, which is again same as 3 by 5. So these two sides are in the same ratio and common angle is A. So SAS criteria, we can say these two triangles APJ and ABC are similar triangles. Okay. This is same as before. Okay. From angle criteria, we can say because angles here are same and both are 90 degrees, which is given. So OAQ and OBP are similar triangles from AA criteria. Okay. Here definitely we can clearly see angles are same 40, 40, 60, 60, 80, 80. So we can say ABC is similar to QPR. Okay. And here all sides are in the same ratio or not. Let's check it. 2 by 5 equal to 2 by 4? No. Okay. So they are not equal. Corresponding sides are not same. So they are not similar triangles. Okay, and here 6 by 2.5 equal to 10 by 5. Is it same? No. So they are not similar triangles. Okay. And here we need to find the value of this one. Okay. It is given that 90 degrees at these two spots. Okay. And other angle. Okay. Angle Q and angle T are same. So angle criteria. These two are similar triangles. So you take the corresponding side, which is 3 by 4.5, which is 1.5 time, right? 1.5 times. So 5 by 5 into 1.5, that is 7.5 is the x value. Okay, x is 7.5. Similarly here 3 by 3, and this angle is 110 degrees, so obviously the other side is 70 degrees, so this is parallel. PQ is parallel to AB, and angle C is same, so these are similar triangles again. So 3 by 3 means it is 1 ratio 1, so 3 by 6 it will become, right? BC is 6, 3 by 6 is 1 by 2. QC is 3, but VC is 6. Okay, so it is 1 by 2. So obviously AB and PQ should be half of AB, which is 5 by 2. X is 5 by 2. Okay. Similarly here, these angles are same and these two angles are same, we know already. Okay. Two intersecting lines, these two angles will be the same. So angle criteria, they are similar triangle. Now let's check the corresponding side. 14 by 24 equal to x by 22. 14 by 24 equal to x by 22. So x equal to 22 into 14 by 24. Simplify that, you will get the answer. Okay, same you can do for other things. Okay, okay. How to construct a similar triangle with a given scale factor? Okay, this is very simple. One triangle is given ABC. Okay, now you need to make 3/4 of this one. So what you do is you draw another line which is multiple of 4 basically, and then it is very easy to mark B1, B2, B3, B4 points, which are 4, basically 4 parts you make it, and then you draw. Fourth part is equal to C, third part you should equal to C1, you will get 3/4 of given triangle. A dash, B, C dash is 3/4 of the given triangle. So this is how we construct it. Okay, let's take the example. Person is 1.65 meters tall, casts a 1.8 meter shadow. Okay, at the same instance, a lamp post casts a 5.4 meter shadow. Okay, so what is the height of the lamp post? This is very simple. This is shade is forming in this angle, right? So these two are similar triangles, 90 degrees here, and these angles will be same. Angle of inclination of light will be same basically. Okay, so these two are similar triangles. Now 1.8 to 5.4 is 3 times. So 1.65 to this lamppost should be 3 times. So 3 times of 1.65 is the answer. Okay, that's 4.95. Okay. Now this is the same example which we started this chapter with. Okay. There is a mirror kept and the person here saw the top of the lamppost here. So these two are similar triangles it forms. Okay. And now you check the ratio. You can measure the remaining distances easily. You know the person height 1.5 meters, distance from the mirror 0.4 meters, and mirror to tower is 87.6. So with these criteria, we can easily uh, map it, and it is 1.5 by h equal to zero point 0.4 by 87.6. Okay, with this h value you can measure easily. Okay. Another example, just go through it. It is exactly similar triangle. Gopal's neighbor is worried about neighbor can peep into his living room from the top floor of his house. Okay. He has decided to raise the wall, okay, fence basically, to such a height which is enough to block the view of the mirror. Okay, this is the uh, wall. Okay. What should be the height of the fence? The measurements are given in the figure. Okay. So this is where the neighbor is there. He can peep into this room. So you have to block it. Okay. You have to block it till this distance. Okay. So you construct a triangle. This is 8 meters given. Okay, so triangles are formed here. Okay, ABD and ACE. Okay, this will form the two similar triangles. Now you need to find the BD basically. How much should be the BD? Because this we know is 1.5 already because this is the height of the roof. Okay, so BD you will get as 0.3 meter. So you should construct a fence of 1.5 plus 0.3, that is 1.8 meter to block the neighbor field. Okay, let's do the exercise 8.2 now. Exercise 8.2. Okay, in the given figure, angle ADE, okay, which is mentioned here, and angle CBA, okay, angle ABD and angle CBA are equal. Okay, show that triangle ABC is similar to triangle ADE. Okay, if AD equal to 3.8 centimeters and AE equal to 3.6, BE equal to 2.1 centimeters, BC equal to 4.2, find DE. Okay, so let's do. So in ABC and ADE, I think we have done similar problem before to prove that the ratio of sides is same basically. Okay, angle A is common in ABC and ADE. Okay, ADE this way. Okay, correct. So angle AAA is common for both of them, and angle ADE is equal to angle ABC, which is given. Correct, given information. So which means by angle similarity, ABC is similar to ADE. Okay, this is proved now. Now, since they are similar triangles, we know that DE by BC equal to AD by AB. DE by BC equal to AD by AB. Correct? Because you check the order of the uh, sides based on the how you wrote the triangle name. Okay, AD by AB. AB I can write it as AE plus BE. Okay. Now, with this information, I substitute the values given and I get the DE value, which is 2.8. Okay. So, if you observe carefully one more thing, if angle D is equal to angle B, okay, and these are similar triangles, obviously DE is parallel to BC, correct? If DE is parallel to BC, angle B is also equal to angle E, correct? So, this will become isosceles triangles actually. Okay, they are isosceles triangles. If angles of these two are same, then it will become isosceles triangle. Okay, next. The perimeters of two similar triangles are 30 centimeters and 20 centimeters respectively. If one side of the first triangle is 12 centimeters, determine the corresponding. Okay, corresponding side of the second triangle. Okay, if ABC are sides of first triangle and XYZ are sides of corresponding second triangle. Okay. Now it is given that these two triangles are similar triangles. Okay, which means A by X equal to B by Y equal to C by Z, which is equal to R. Correct? Fixed. Now A equal to, that means A equal to Rx, B equal to Ry, C equal to Rz. Correct? Now what happens to the perimeters? A plus B plus C equal to Rx plus Ry plus Rz, which is R times X plus Y plus Z. Okay. Now R is equal to A plus B plus C by X plus Y plus Z. Correct? Which is nothing but a ratio of these corresponding sides. R is equal to ratio of corresponding sides. Correct? So one side is given, two sides are given corresponding sides, which is 30 centimeters and 20. So R is equal to 3.3 by 2. Okay? And it is given that A, one of the side is 12. Okay? And then what is the corresponding? Okay? A by X equal to 12 by X, okay, which is equal to 3 by 2. So X is equal to 8. Okay, corresponding side in the second triangle will be 8 centimeters. Okay, next. In the given figure, AB is parallel to, okay, AB is parallel to CD is parallel to EF. Given that AB equal to 7.5, okay, DC equal to Y centimeters, given EF equal to 4.5, BC equal to X, CF equal to 3, find X and Y. Okay. Yeah, this is also simple because we have so many parallel lines and so many triangles we can see. So there are so many similar triangles which are possible in this. Okay, let's see what is required for us. Okay, we need basically CD and EF, right? So you always concentrate on triangles which have these sides. Okay. Now first let's find one of them. So ABC is ABC ABC is similar to EFC. EFC. Okay, why do I need this? Because this is obvious similar triangles which we can see here actually. Okay, these angles are same since EF and BC, AB are parallel. Okay, so angle E here will be equal to angle A, angle F here will be equal to angle B here. Okay, so which means they are similar triangles, correct? Since they are similar triangles, take the sides ratio basically in the same way, EF by AB, okay, CF by CB or BC equal to, that implies 4.5 by 1.5 equal to 3 by x, which means you got x value which is 5 centimeters. Okay. Once you have x, we know that in FBE, these two are parallel lines, so you have similar triangles again, correct? BEF in triangle BF, CD is parallel to EF, which means BDC is parallel to BEF. Okay, now you substitute again the remaining values, you will get the value of y. Okay, y is equal to, sorry, okay, y is equal to around 45 by 16. Okay, next. A girl of height 90 centimeters is walking away from the base of a lamppost at a speed of 1.2 meters per second. If the lamppost is 3.6 meters above the ground, that means height, find the length of her shadow after 4 seconds. Okay. So she has walked from base here. Base is a D. This is lamppost. D is lamppost. From here she has walked to point B in 4 seconds. Okay. In 4 seconds. Okay. That means how much distance it will be? Speed is 1.2 meters per second. So 4 seconds. It will be 4.8 meters. So BD is 4.8 meters. Okay. Lamppost is 3.6, which is given. And the height of 3.6 meters. Okay. Height of the girl is 90 centimeters, which is zero point 0.9 meters, you can say, right? So lamppost is 3.6, girl height is 0.9. Okay, distance from the lamp after 4 seconds is 4.8 meters. Shadow is AB. Now we need to calculate AB basically. Okay, so BC is parallel to DE because both are at 90 degrees to the ground. Okay, so we can prove that ABC is similar to ADE, right? Since this is parallel, okay, 90 degrees here, 90 degrees same, common angle, A is common. Okay, so ABC is parallel to ADE, which means AB by AD equal to BC by DE. Now AB by AD is nothing but AB plus 4.8, okay, which is equal to 0.9 by 3.6 or 1 by 4. So we can get the AB value after simplification, which is 1.6 meters. Okay, this is the shot of the girl. Okay, next. So given that ABC and PQ are similar triangles, CM and RN are the respectively medians of ABC and triangle ABC and triangle PQR. Prove that uh, AMC is similar to PNR. Okay, and second part also triangle CMB is similar to triangle RNQ. Okay, of course, one more is that CM by RN equal to AB by PQ. Let's see one by one. First thing is ABC is similar to PQR, which is given. So AC by PR equal to AB by PQ. Okay. Now AB is nothing but 2 AM. because this is median, m is median, n is median. So 2am by 2pn, which is equal to am by pn, correct? So that means angle A and angle A is also equal to angle P, which is also given, correct? So that means in angle AMC and an angle PNR, ratio of AC by PR is same, correct? And ratio of AM by PN is same as ratio of AC by PR, okay? And then the in between angle is also same. That means from side angle side rule of similarity, we can say these two triangles are similar. This is the first part, okay? Since CMB is parallel to RNQ, okay? CMB also similarly we can prove that they are similar triangles. So they are similar. So CM by Rn equal to CM by Rn equal to MB by NQ. Okay, which is again you substitute the values, you will get okay. So this is the second part, CM by Rn equal to in the given pictures here, okay. Triangle ABC is similar to triangle PQR. CM and Rn are respectively medians of those two triangles. These are the medians, which means AM equal to MB, PN equal to NQ. Okay, we need to prove these three. Okay, let's take one by one. Triangle ABC is similar to triangle PQR, which is given information. Correct. So AC by PR equal to AB by PQ. Okay, take in the same order. AC by PR equal to AB by PQ. Okay. Now AB is nothing but 2am because M is the median, M is the middle point of AB. Okay, and N is the midpoint of the PQ. So 2am by 2pn, which is equal to am by pn. Okay, and we also know that angle A is equal to angle P because they are similar triangles, right? Now from side angle side rule, okay, which side AC by PR is equal to AM by PN, which we have derived just above, and the angle in between those sides are same. Okay, which means from SAS rule, we can say that triangle AMC is similar to triangle PNR. Okay, now once we prove that one, triangle AMC is similar to triangle PNR, which means Cm by Rn is equal to Am by Pn, correct? So Am is nothing but AB by 2, PQ is nothing but, Pn is nothing but PQ by 2. So that means the same ratio is Cm by Rn is equal to AB by PQ, which is the second question, right? Now third, CMB is similar to RNQ. We can prove exactly same as first part, okay? Or we already know the ratios of the sites, so with that also you can prove. So we can either use SAS rule or SSS rule to prove it, which is exactly same as first question. Okay. Next, diagonal CC and BD of trapezium ABCD with AB and AB is parallel to DC intersect each other at the point 0. Using the criterion of similarity of two triangles, show that OA by OB equal to OC by OD. Okay. Yeah. Let's see. So in triangle ABO and CDO, ABO and CDO, okay, this angle here is same, okay, correct? This angle is same, okay, and the angle here, A angle is equal to C angle because AB and CD are parallel and AC will be the transverse, correct? And B angle B here and angle D here are same, so they are similar triangles by angle rule, okay? Now, once you know that, we can prove that these two are similar triangles. Now, you take the ratios. OA by OC equal to OA by OC equal to OB by OD. Okay. Now, you adjust it basically, you will get OA by OB equal to OC by OD. Okay. Very easy. Just playing with similar triangles. Okay. There are so many hundreds of things which we can create from a similar triangle in the geometry. So you should be aware of all these things when you go to higher level problems. Okay, you have to use this property of similar triangles and then derive the values which you require. Okay, next. Okay, so look at the above picture. AB, CD, PQ are perpendicular to BC. Okay, if AB equal to X, okay, CD equal to Y and PQ equal to Z, prove that 1 by X plus 1 by Y equal to 1 by Z. Okay, so this is also will prove using similar triangle concept. Okay, in triangle ABD, okay, ABD, okay, this triangle, okay, PQ is parallel to AB, PQ is parallel to AB because both are perpendicular to BD, so these two are parallel, okay, which means ABD is similar to PQD, PQD, okay, which means DQ by DB equal to PQ by AB, okay, what is that? PQ by AB equal to DQ by QB, correct? Yes, okay. DQ by DB, sorry, yeah, full triangle you have to take, right? Two triangles, okay. So that is equal to Z by X, okay, correct? Because we know that DQ by PQ by AB is Z by X, okay. Now this is first equation. Second equation is in triangle BCD, okay, BCD, okay, BQ by DB, BQ by DB is equal to PQ by CD, like, which is equal to Z by Y. Okay. Now, if I subtract 1 minus BQ by BQ, 1 minus BQ by DB is equal to 1 minus Z by Y. Correct? 1 minus BQ by DB is nothing but DB minus BQ by DB. Okay. DB minus BQ, which is nothing but QD. Correct? Or DQ. So DQ by DB equal to Y minus Z by Y. DQ by DB we just proved in the first equation. If you see, it is nothing but Z by X. That is equal to Z by X. Now simplify it, you will get 1 by X plus 1 by Y equal to 1 by Z. Okay, next. A flagpole 4 meters tall casts a 6 meter shadow. At the same time, a nearby building casts a shadow of 24 meters. Okay, how tall is the building? Okay, now we need to create similar triangles using this information. This is AB is the building. It is casting a shadow of 24 meters, that is nothing but EB. Okay, and CD is the flagpole, okay, which is 4 meters tall, okay, and this is casting a 6 meters shadow here, 6 meters, okay, out of 24, this total 6 meters is this one, okay. Now we need to find out AB value. This is the height of the building, correct? So pole height is 4 CD and the shadow height is ED, which is equal to 6 meters, pole shadow, that is. Building shadow is EB, which is 24 meters, okay. Now we need AB. Okay. From similar triangle rule, because CD is parallel to AB, similar triangle rules, AB is similar to CDE. So CD by AB equal to ED by EB. Okay. Which means CD is, we have the three values, basically we substitute them, we get the fourth value, that is AB, which is equal to 16 meters. Okay. Next. CD and GH are respectively bisectors of uh, angle ACB, okay, angle C and angle G. Okay, such that D and H lie on the AB and FE of ABC. Okay, on the opposite sides basically. D and H are on the opposite sides. Then you have to prove these three. Okay, which is similar to the ones which we have done before actually. That's it. Triangle ABC is similar to triangle FEG, which is given data. Okay. Then angle ACB is equal to angle ACB equal to angle FGE. Correct? Yeah, because they are similar triangles. Now CD and GH are angular bisectors. Okay, all four are equal as shown. So these are all will become theta, 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 theta. Correct? Equal angles because this is a bisector of angle. GH is also bisector of an angle. Okay. Now, first we'll look at the second one. We'll prove the similarity. So DCB and HGE, angle DCB is theta. Okay, and angle HGE is also theta, which is same. And then angle CBD, okay, angle CBD is equal to angle GH, which is common because they are similar triangles, they are equal anyway. So angle rule, we can say these two are similar, which is second part, right? The third part is DCA. DCA is similar to HGF. We can prove it exactly same way how we done above. Okay. Now the first part, coming to the first part, because these two are similar triangles, CD by GH equal to AC by GF. Right? Then you adjust it. CD by AC equal to GH by GF. Okay. That's it. Next. AX and DY are altitudes of two similar triangles, ABC and DEF. Prove that AX by DY equal to AB by DE. Okay, ratios basically. Okay, it is exactly same as before. Since it is the altitude, we can take the advantage of angle AXC or AXB is 90 degrees. So it is much more easier to prove that they are similar triangles actually. Okay, next. Construct a triangle ABC with your own measurements. Construct another triangle similar to ABC with its sides equal to 5/3 of the corresponding sides of the triangle. Okay. So I just don't want to show it here. I'll just explain it. You can do it yourself. They're very simple. First, build a ABC triangle with, let's say, multiples of 5. Okay. Sides are multiples of 5. That way, with the scale, you can easily mark 1 centimeter distance. Correct? Then you take the third centimeter and then draw the parallel line to the third side. That way you will get 5/3 of the uh, 5/3 of the sides of the original triangle. Correct? So that is how we should do. Okay. So you cut it like this. Okay. And then cut the other side also. And then which one you have to make? You to get 5 by 3, this one, right? Because each one is 1 2 3 4 5 parts. I'm taking 3 parts. If you join these two, this will be parallel to the third side and all the sides will be 5/3 5 by 3 ratio. Okay, this is how we'll construct. Okay, next. These two also exactly same. You can look at the previous example and then just construct in the same way. Okay, so let's close this video now, but not the chapter. Okay, we will continue on the next video. And what we cover in the next video is basically areas of similar triangles, how they behave. Ratios are same as sides, or what is the this one? Some exercises, and then Pythagoras theorem and Baudhayana theorem. Okay, uh, we'll see what is the difference there. Okay, we normally know a square plus b square equal to c square as Pythagoras theorem, but historically it was much before recorded in the Indian scripts actually as Baudhayana theorem. So we'll just renamed it to be more precise and correct. Okay, we'll learn these things. Then different forms of theoretical statements, a very simple concept, and some more exercises and optional exercises. Okay, see you in the next video.